something that we see every day, that makes us able to sleep at night, and what makes us to wake up in the morning. This is simply what makes us human beings capable of living. I'm talking of course about the sun, the big star that is closest of all the billion stars in the universe. A phenomenon that is so extremely big that it would take over 200 days for an ordinary aircraft to drive around it, while the aircraft would fly around the Earth in 30 hours. The sun may not look overly much larger from the Earth than the moon, but if we compare the sun with a football having a diameter of 22 centimeters, then would the moon have the same size as an ordinary grain of sand that can be found on the beach. This is because the moon is so much closer than the sun. The sun's distance from the Earth is almost 150 million kilometers. The sun gives off, of course, extremely much energy into light, sound, and especially heat. Can the sun live and keeps us warm forever? What happens when the sun's energy runs out? But first, how can such a huge phenomenon like the sun be created? It takes enormously amount of energy for a star to be created. Everything starts when there are gravitational statistics in a molecular cloud that is often created by the shock wave from a supernova. It is a force wave created when a star has exploded. The waves may come in the form of neutrino or massive amount of radiation. The gravitational statistics in a molecular cloud can also be created when two galaxies collide. This leads to a mighty force that are triggered in all different directions. This creates a so-called Book globule. It is an enormous cloud that may have a diameter of 1 light year. It brings together molecular hydrogen, carbon, and helium. The mass collected can be up to 50 times larger than a typical shooting star. Then, when the Book globule created is collapsed, the density increases, and the gravitational energy will be converted into heat, and it will result in the temperature in the low-developed star to increase significantly. In the Book globule's cores will after time density increase and a protostar is created. This is the last step before the star reaches the process called main sequence. When a star reaches the main sequence, a star is developed, and this is the type of star that we can see from the Earth. The star spends about 90% of its lifetime in the so-called main sequence. Hydrogen begins when they merge hydrogen and helium with each other under extreme pressure and temperature. This means that the number of helium in the star's cores will increase, and then the temperature will rise. The Milky Way's stars is estimated to have increases its luminosity, which means brightness, with about 40% since the star was created. A star that is already known is burning and giving off very much energy. Even though the stars gives out so much energy, the normal length for a star to live is 50 million years. This varies, of course, from star to star. The biggest stars lives only 1 million years, while a dwarf star can live up to 100 billion years. When the hydrogen in the core is finished, the size of the star rises very quickly. When the sun ends up in this state, it will gorge Mercury and Venus. Many theories have involved that the Earth will increase its distance from the sun when the mass decreases, but the opposite is most likely to occur, and the Earth becomes a part of the sun's collapse. A star's size will decrease until it's as big as the Earth. then it will not be able to shrink anymore. This is called a white dwarf. On the picture are you able to see a comparison with the Earth and the white dwarf. After a long time, the white dwarf, after much cooling, it will be called a black dwarf. In the end, the main core will collapse and create a supernova explosion. It is a beta decay that is created when electrons are forced into the protons in a nucleus of enormous pressure. After the supernova explosion, the bulk of the mass to fly away, with what remains it will be called a black hole.